Guys, this is Gandhi Pencil of JP Noida from India. Now here I am to discuss my major project, which is evolutionary algorithms and analysis and a new approach to crossover and mutation. Now guys, evolutionary algorithms, or as I'm from now going to call them genetic algorithms, are a kind of search technique which mimic the nature's process of selection. Now the nature's process of selection is that we select two individuals, they create an offspring. The offspring inherits the best characteristics of the individual, and then further on, so after every generation a better set of individuals are created. The genetic algorithm also mimics the same thing. So it is the basic algorithm for it is here. In the beginning we create a particular set of individuals or chromosomes, as we in this particular algorithm we are calling them. So some random population is generated. Now the population generated can be represented in many forms, like they can be represented in a permutation, as integers, as floating point representations, or as binary. In my particular project I have just concentrated on the binary part. So now we evaluate the fitness of it in the next step. What is fitness? Fitness is like how close the chromosome or the solution which we are getting, the individual, is to the actual solution. Now fitness function, they just compare the actual property of the individual to that of the solution, so that we can get a general idea of how fit a particular solution is. Now I'll give you an example here. Like for this particular chromosome, if we calculate the number of ones, 1 2 3 4, so there are 4, so its fitness is 4. In it there are 7 ones, so its fitness is 7. So guys, the next step is that we select two chromosomes from the population. Now there are many methods of selecting: tournament selection, roulette selection, also like stochastic general selection. There are so many methods, but generally we use tournament selection. Tournament selection is that we define a tournament size like of 5, and then we pick out the best random 5 individuals from the population are put into it, and we select the fittest individual out of these two groups. So after that we apply crossover and mutation, and thus we create the offspring. Now this brings us to the most important point: what is crossover and what is mutation? Now crossover basically means here, like we take two parents, parent 1 and parent 2. Crossover means that how the characteristics or the bits of parent 1 are gonna come in parent 2, or are gonna come in child parent 1 and parent 2. So there are many ways of calculating it. Like there is the single point crossover. Single point crossover, as the name suggests, that we take a point, the crossover point, which is how it is known, and then we put the bits of parent 1 up to that point and that of parent 2 after that. Here 0 and 1 of the first parent are put here, and 1 0 0 1 0 of the second parent is put here. This is the way of making of how we create children. So now there are other techniques also, like two parent point crossover, like the name suggests, that we just take 2 points instead of 1. There's intermediate crossover, heuristic crossover, arithmetic crossover. There are many kinds of techniques, many kind of crossover methods. So basically what crossover means, I hope I am able to clarify it, that it means how, in what sense that the characteristics of the two parents are going to come into the child. Now the next thing is that mutation. Now mutation is a very important step in this particular search algorithm, because it helps us in the property of exploration. Now what is exploration? Here you will be better able to understand it. It's a local optimum, it's a local optimum, it's a local optimum, it's a local optimum. Now if we consider a hill climbing algorithm, it will arrive at a particular local optimum and then it will stop, and because it doesn't know that there are other algorithms, there are other optimums as well. For that, like we are generating individuals in this area, like the first random generation, and this is the problem space. So if we just apply crossovers, we will get solutions in this area only. We will never get solutions outside of this area, maybe some. Now by the property of mutation, we explore the problem space. Mutation means that we randomly alter the bits of the solution of the individuals of the solution, like the child. To better make it clear, I have another way here. Now what crossover, I have explained you what crossover is. Mutation, in this there is this bit 1. Oh, yeah, second bit, it's 2, we randomly change it to 3. Now through this we are able to produce variations which don't depend on these two parents or these two individuals. Thus we are able to create different individuals for the next generation, so that we can explore the whole problem space. Now I'll clear this out. Yes, you can go switching. So guys, this is what the algorithm means. I have explained to you what crossover means, what mutation means, and how we get the child. Now this child, at the end of every generation, the child is compared, that whether it is closer to the final solution or not. We can classify the whole procedure through this. We have a old generation, the generation which we start with, we calculate its fitness, then we select individuals out of it, we apply crossover on them, then they are mutated, and thus new generation is created. Now for the next iteration it becomes the old generation and its fitness is calculated. So guys, this is